So, good morning. I hope everybody had a good time last night. I know I did, so I'd like to thank LINX for having me, and I'd like to say happy birthday, happy 30th. And yeah, my name is Paul Dunbar. I'm a network architect at Akamai. I have different regions that I'm responsible for, but one of them is the UK and Ireland. What we're going to concentrate on today is talking about the UK and how we're delivering into that region. And yeah, let's get into it. So here's the agenda. I'm going to talk a bit about who is Akamai, talk about what we have in our marketing slides is the Akamai Intelligent Platform, which is the content delivery network. Then we'll dive into the UK and see what's going on there, how we evolve that, increase that, and then we'll finish off with a little précis on the Euros. So this is the statement of saying the world's most distributed platform for cloud computing, security, and content delivery. That is Akamai. So it used to be a content delivery network from its origins, and then it's branched out into the compute and security industry as well. So there's a few numbers here about the CDN part of things, which we're concentrating on today. Here we see a few numbers, but the one I want to zoom in on is the bottom one, which is the delivering roughly 300 terabits daily. There are peaks which nearly get to 400, but yeah, it's around that number that we're serving globally. Let's go back to the UK. So let's zoom in there and see how the UK contributes to those numbers. We see daily peak traffic between 17 and 20 terabits. It's the second largest country for traffic delivery globally. We're distributed in 12 cities. That includes where we have our public infrastructure in London and Manchester, and also where we're delivering into the ISP's networks directly. So that's where we have our AMP cluster, which is an Akamai cluster. Of course, we need servers for that, so there's roughly 19,000 distributed across the country. And then we have different deployment types, which I just referenced, which was the AMP. And then we've got the PNI connectivity with exchanges and then transit. So yeah, we don't just deliver it into the UK. We also deliver to African countries which don't have the same infrastructure. We don't have the same reach in. So yeah, that's a traditional thing that's still going on. But there is development in Africa, and it's growing, as you heard just now. So yeah, the other thing is we deliver also into EU countries. Due to proximity, because the scores that we use to have a distance on how we think the end user is close, basically is used as a massive indicator to say, this is where we need to send it, we want to serve it locally. That does mean we do serve to the EU, especially in overflow situations, and it can be that it reverses the other way, that EU countries can also serve the UK as well. So how do we meet our traffic demands? We do forecasting, we do half-yearly cycles. With our modeling, we try and get lots of inputs to work out what is going to be the new traffic for that year. We get the inputs from our partners. They have inputs from their customers. We have our direct customers, which we get numbers from. We look at traffic trends, so that can be seasonal. There's more in winter than there is in summer, traditionally. It depends if there's an event on. But there's also regional and country level kind of trends which have their own traffic profiles. So that influences those decisions too. There's organic growth year over year. So that's in the calculations. And then there's what events are coming up. So for example, we will talk about it later, but the Euros and sports events are things that give us peak traffic, maybe outside of our normal seasonal trend. Inside of those numbers are also baked some headroom, and so some buffer and margin to have some buffer when there is unexpected traffic events or larger delivery volumes than we expected. And it's a resiliency point of view as well. Because not always the platform stays up and stable, so you have to cater for that as well. And then we talk about the quarterly capacity reviews and the actual deployment cycle, which is the implementation part where we actually put the servers into the locations and get bandwidth up and ready for serving. This part also has the resiliency review. This is where I come in with the network architect hat on to look at how we make sure that we have enough bandwidth and server capacity in the region to make sure that we deliver for the demands that we see or forecasted in our trends. So that's the quarterly part is a kind of like a reaffirmation or an adjustment of like what we're building towards as a yearly cycle. So we talked about the platform, and now we're going to dig into different parts of it and talk about the trends that we see inside of the UK. We have the AMP side. So let's talk about the trends that have happened in the UK over the years. We're building larger sized AMP deployments for our major providers inside the UK. This increases cache efficiency and performance because we're able to keep particular objects on for longer, so we don't have to keep downloading them. So we need to do that because of the traffic volumes. And then there's an economy of scale where you want to use that to push lots of volume traffic over those clusters. So that's something that's happened there. The second part is smaller AMPs are being phased out. That means that for the providers where we've originally tried to get as much reach into a country as possible with our AMP deployments, from the smallest provider to the biggest, we're tending to go away from that because we don't have the justification to put the servers in, and we've talked about the cache efficiency and the performance angle as well. So we're tending towards offering those providers PNIs instead of having AMP clusters directly in their premises. And for people that don't, or companies that don't justify having a PNI, because the smallest PNI we have is 100 gig port. We do 400 gig ports now as well. We have a threshold there for basically looking at different ISPs and saying, yes, we see that volume's going to be roughly about 20 gig over the year, so yeah, we can go for it. But if it's less than that, we have to see how the traffic is going to grow and what the forecasts are projected from the partner to justify it. Because we do have some port availability issues, but then we're also scaling that, as we'll talk later. And if we can't connect directly with PNIs or with AMP, then we look at the capacity we can get over internet exchanges, just like the one I'm presenting at. So yeah, that's the AMP side of things. And then we talk about public infrastructure, where we are based in London and Manchester in different data centers in London, only one in Manchester. So that's where we have our bigger clusters, which feed into the AMP for cached ingest and delivery there. There's also delivering directly from it as well. So these clusters have also got bigger for the same reasons as the AMP clusters. We've got the terminology fabrics here, which is basically our building block for building these big public infrastructure clusters. They're big in terms of how they can scale, so like 10 terabit, for example. They are built in with a resiliency design of spine and leaf, so that we can have more resiliency inside the cluster itself. Because in the past we used to have more clusters which were smaller and distributed across more data centers, but we're tending away from that model and now going into this design where we have fabrics. The other thing that we do is that we have connectivity upstream sites, which are expensive and don't have the scalability to grow our footprint for our servers. So therefore, we put the servers downstream in a data center that can house that, and then we backhaul that with DWM. So traditional DWM with transponder, et cetera, et cetera. So that's how we're increasing the size of those and putting more servers in there with bigger regions. That means bigger sets of clusters that have particular purposes. And we're building on the PNI and IXP capacity, and also the transit capacity that we use both locally on the actual cluster itself and also via the backbone. So yeah, you can see our partner and customer connectivity over the PeeringDB platform. So that's pretty up to date. All right, so we talked about the platform. Let's talk about the backbone. We didn't always have a backbone. we do now, and you can see how it's grown. We're everywhere, it looks like, but you can see dotted lines which lead towards India, from Marseille to Mumbai, I believe, and from Chennai to Singapore. So those are in planning. The rest are all in there, and that's the latest version we've got of that slide. So we are building with different size bundle links. We're using 400 gig links, and yeah, we're looking at the number at the bottom left here, which tells us how much capacity we're serving over the backbone over our long-haul links. To give an idea of how much we're serving in general, like 300 terabits for the edge delivery, the final delivery, and all the other components that go into that with midgress as well. And then we see the 100 terabits, which is supporting that for just midgress delivery, origin fetch, and also edge delivery as well. So we're trying to show how the backbone is supporting that. Why do we do this? Why don't we just use transit? Well, we're trying to cut costs and deliver it ourselves. So that's the main argument for that part. So let's go back to the UK again and zoom in there. With an ever-growing CDN platform implies an ever-growing backbone. We've been increasing our capacity builds continually. We have links connecting between the metros, so London to Dublin, London to Manchester, and then we have London to the EU metros, as well as across the Atlantic as well. So all those things just need to be continually upgraded as the traffic volumes go up. With this model, we've been having to scale, and we've had to get bigger routers and all those kind of things. And this is where we now start talking about a new backbone design for Tier 1 metros globally, which includes London. And I'm happy to say we completed this project just about a couple of weeks ago. So I'm quite proud of that with the team there. So thank you very much, guys out there. So shout out to you guys that got it done. And yeah, let's talk about that design. The design is called the Metro Aggregation Architecture, so MAG for short. It's also a spine and leaf topology, where the MAG routers are the spine, and then the routers that hang off of that are called the leaf. So we'll come to exactly what those are and what role they play. What are the features of this? We have the ability to scale better now, both inside the data center and between data centers. We can scale horizontally with the leaf routers, and I'll tell you what they are in just a second on the next slide. And another thing that's really cool here is we have the P&I connectivity in different data centers. Before, we could only serve traffic from those P&Is connected to the backbone and use the local connectivity of the Akamai clusters that are connected to the backbone at that particular DC. But nowadays, we can serve traffic from a P&I that's in, say, Slough, for example, LD5, and then we can have that capacity being used in, say, Telehouse or further downstream to actually use that. So we've got metro level usage of our P&Is now, where before it was on a DC level. All right, so this is the acronym page of the stuff that we talk about daily inside of Akamai. We'll start with the ICN in the middle. This is our intercity network connecting our metros, whether it's locally in a country or we're doing long-haul subsea capacity interconnection like we spoke about with the transatlantic as an example. Then we talk about the IEN. This is a local aggregation point where we connect all of our clusters which have all the servers which then serve the bits for the CDN, but it can also be for security platforms that we host, and also for compute, which is growing massively at the moment. So we're putting a lot of investment into that, and those compute clusters and I would say CDN or edge clusters are growing in tandem. So they're part of the same build normally. We have connection to our cloud providers and ISP networks that can go directly onto the IEN. So that's where the interconnect point is mainly for external providers and customers. Which then talks about the direct connect that we have, which is Akamai Direct Connect, and there we can have customers directly connect, say for origin fill, and that's how that then connects to the IEN as well. So I'll show a diagram of that, and we'll have some pictures now to back up those words. So let's start from the top down. we've got the global ICN backbone, and that's the cloud, which basically is showing the big global map that I showed at the beginning of the backbone section. Those are connected with intercity waves. This is a one data center viewpoint, and this is the old design that we had. So we'd have like a shoelace design where the ICN connects to the outside world and then connects downstream to the IEN routers. And then they connect to the clusters which deliver the bits, or the AADC routers which connect to our customers. And we have our P&I capacity, and we have had, I don't know how long, but we now connect transit also to the IEN as well for cache fill into those clusters, not just local to the routers that are on the clusters. This is an N by 100 design, and now we're evolving to the next design where we put the MAG in. So we talked about the fact that this was a spine and leaf design, and we have the MAG being the central part of that spine. And we have then the leaf routers, which I mentioned before, being the ICN and the IN routers. So when we talk about the leaf routers, it will be about those two types of routers. We talked about how the scalability works. Here we see the example of addition of more ICN routers or IN routers as need be. And this allows us to add the same type of device, not upgrade an existing device or pair of devices. It would have to be for the ICN in the original example we've got here. So it scales easier. We can use a modular design to get the capacity that we need. So that's one massive benefit from it. The second part here we're looking at is the metro connectivity level here. So what we were looking at before, was a one data center viewpoint. This is now a two data viewpoint. And this is described by DC1 and DC2 as being the different data centers. We see how they now interconnect with each other and how they then scale up with that design in mind. The design here is a little bit different to how we've done things in the past, and that's all because of the MAG. The central premise here is that everything connects to the MAG, whether it's remotely or locally. So there'll be connections from, say, IEN2 in the bottom left corner to have a connection up to the ICN2 router. And we basically have changed our design from having the ISIS mesh on the ICN level only, and now we brought that down into the MAG level. That then gives us the chance to make LSP mesh, and that also enables us to have IBGP topology fully meshed as well. So that's the big distinction between what we've had before and what we have now. The other thing is that this design also has a 400 gig connectivity aspect to it. So all those links are 400 gig and bundles thereof for the capacity. How we then connect remotely is basically between the sites, let's say inter-metro connectivity, is over 4 DWM systems over 4 dark fiber paths. So we have passive muxes that are going over those fiber paths, and then we have colored optics or tunable optics, which are on the actual leaf routers that we spoke before, and then they make the remote connectivity using those wave signals with those frequencies. So that's how it scales in terms of all the connectivity, and that's how we achieve the goal of having P&I connected to, say, IEN2 again, being able to serve clusters that are based in DC2 on the other side that hang off the other IEN routers in the other data center. I think it's worth noting how we connect for ISPs and how we connect in the backbone. We've reduced our footprint for how many data centers we are in for the backbone. So our primary two sites are Equinix LD5 in Slough, and the other cage we have is in Telehouse North 2. So that's for the backbone connectivity specifically, but we still connect to providers for P&I connectivity and transit in Equinix LD8, Equinix LD5, and Telehouse. So why do we do all this? We want to deliver bits so that people can watch football and enjoy themselves, hopefully watch your team win and all that stuff. And we have talked about the forecasting of it. We've talked about how we have to scale the platform to meet those demands. And we've also talked about how the backbone in Tandem has to scale. And we've talked about the new design of that, which is being implemented globally. So this pretty much final slide is talking about the numbers solely for the delivery of the UK broadcasters. We can see the trend going up as the games progress, and we can also see that because of how far England went into the finals. We can see that Scotland started the game with the inaugural beginning game, and they had 4 terabits, and it stayed around that for the rest of the group stages. The England games, with of course having a larger population, started at around 7 terabits, and then as the games got further in, more people got interested in watching it, to the point that it was like 13 terabits delivery at the end, roughly. So yeah, that's solely the football. We haven't even talked about the amount of traffic we're serving for the normal day-to-day traffic, say for downloads or video on demand, all kinds of stuff. So that's in Tandem, and that's what we have to cater in for. So we've talked about a few of those points. The last piece I want to bring up is the streams and the actual bit rate that we use. And this is kind of an interesting point here, I think, because we've talked about how big those numbers were, and we can also talk about how big they could have been. UEFA decided to use at maximum HDR streams, which have a lower bit rate than what we've seen in the past for other tournaments, where we've used 4K UHD streams, which can go up to like 25 megabits per second delivery, which would of course increase all of those numbers if we were to do that. But I think it's, in my opinion, it's a sensible decision to have the same experience with a lower bit rate, a good feel to it, because there's talk about how you use different streams for how the viewer views it. And yeah, there's been a compromise made, and it'll be interesting to see how future events are also decided in terms of which bit rate. So yeah, that was me. That was my slides, and thank you very much.
That's great. Thank you very much, Paul. Is there any questions in the room? Okay, and anything on Slido? Okay, excellent, brilliant. Okay, thank you very much, Paul. Appreciate that.
Thank you.